Hi, this is Bradley Bush. Today we're talking about another topic in algebra, exponential notation. And then later on we'll have some rules for exponents, which are actually super helpful. Exponential notation is seen all over the place in algebra. So if we look at something like 3 to the 5th power, like we have right here, the 3 is considered our base, and the 5 is the exponent. So 3 to the 5th power, that's actually the same thing as saying we have 3 multiplied by itself 5 times. So if we look at to the right here, we see 1, 2, 3, 4, 5. 5 of them. So we have 3 multiplied together 5 times. So if we look at this together, this is the same as 3 to the 5th power. Base exponent, really that's all there is to exponential notation. So x squared is really the same thing as x multiplied by itself twice. A to the 4th power is really the same thing as a multiplied by itself 4 times. B cubed is the same thing as b multiplied by itself 3 times. And 2 to the 5th power is the same thing as 2 multiplied by itself 5 times, which is 32. Now let's talk about exponent rules. Exponent rules are really helpful. I see students on a regular basis make mistakes that deal with exponent rules. So if you can master these exponent rules, I think there are 8 of them, you will do yourself a big favor. So let's talk about them. The first one is the product rule. So if you have a to some power m multiplied by a to some power n, then what you do is you keep the same base, a, and you add the exponents. So our example to the right, we have x squared times x cubed. That's the same thing as x to the 2 plus 3, which is x to the 5th power. Second rule, if you have a to the m all raised to the nth power, so here we're not multiplying two things with different exponents but the same base. We're taking something to a power and then to a power. They call this the power rule. So what we do is we actually multiply the powers together. So if you have x squared in our example to the right, x squared raised to the 3rd power, that's the same thing as x to the 2 times 3, which is x to the 6. So notice these are not the same. These are not equal. Oftentimes students get those two mixed up. Let's talk about the quotient rule, number 3. So if you have a to the m divided by a to the n, and a, by the way, the base cannot be 0. You would have 0 in the denominator. So if you're dividing two things with the same base, you can subtract their exponents. You take the top exponent minus the bottom. So in our example to the right, in this quotient rule, we have 3 to the 4th minus, or divided by 3 squared. I don't know why I want to subtract everything, but it keeps coming out in the audio. So don't listen to what I'm saying, listen to what I'm doing, if that even made sense. 3 to the 4th divided by 3 squared gives us 3 to the 4 minus 2. We subtract the top exponent minus the bottom, which gives us 3 to the 2. And 3 to the 2 is the same thing as 9. All right, rule number 4. A to the 0 power equals 1. This is the 0 exponent rule. This is useful because anything raised to the 0 power is 1. It doesn't matter what that is. It could be 5 raised to the 0 power. It could be -1 raised to the 0 power. All those equal 1. But remember, this is not the same thing as this. because the exponent 0 is applying only to the 5 here, not to the negative out front. That would be negative times 1, which is negative 1, just as a side note. So 5 to the 0 power in our example to the right gives us 1 from our rule. So that's sweet. Rule number 5, the negative exponent rule. So if we have a raised to a negative power, negative m, then the negative in the power right here doesn't tell us that the quantity is negative. It tells us that the base is in the wrong place. The base needs to be flipped. So the base comes down at the bottom, and we have 1 over m, 1 over 8 to the m. And notice here the m is in the correct place now, so the negative is not present. This is called the negative exponent rule, and in our example to the right, we have 2 to the negative 3. 2 to the negative 3 is the same thing as, so we need to flip the base. We have 1 over 2, all raised to the positive 3. So the negative goes away once we flip the base, or take the reciprocal. It's the same thing as when I say flip the base. Now we can apply the exponent 3 to everything, which, by the way, we'll get down here in rule number 8. But I'm going to do an example now. 1 to the 3 is just 1. And we have 2 to the 3 there. So we have 1 over 2 to 3 is 8. Awesome. Rule number 6. This is also a negative exponent rule, but we have the negative exponent this time in the bottom. So again, the base needs to be flipped, so this in effect comes to the top, and the base, or the base stays the same, but the exponent changes from negative to positive. So our exponent here is negative 2. It's negative, so this comes up to the top. So we have 1 over, if we flip the base, we have 1 over x. Now the exponent is positive. We can apply the exponent to each, the top and the bottom, so we get 1 squared divided by x squared. We need to take this in the denominator here, flip it, and multiply by the top. So that gives us 1 multiplied by x squared over 1, which just gives us x squared. So you can see the x term, x negative 2, ends up coming into the top right there, just like we have in the rule. So rule number 7, we have the product to the power rule. In this rule, we take the power. That is a terrible arrow. I need to go to arrow school, I think. We take the power and we apply it to each term in the product. An important thing in here is that a must be multiplied by b. This must be a multiplied by b raised to a power. It is not the same thing. That's not equal. That's what that symbol there means, if just in case you were wondering. This is not the same thing as this. A plus b to the m power. This right here is a foiling problem. It's a multiplication problem, not a product to a power problem. So please don't get those confused. I'm going to do a no sign on that. So back to the power. We apply the power m onto a and to b, and that gives us a to the m and b to the m. So over to the right, in our example, if we apply this power 2 to the x and the y, we simply get x squared times y squared. Rule number 8, the last one. This is called quotients to powers. if we have a divided by b, and it's all raised to the nth power, then we can take that power and we can apply it to each the a and the b in the top and the bottom. So this is what I was doing above in rule 5 and 6, just in case you were wondering. I apply the power of 2 to x and 3, and I get x squared divided by 3 squared, which gives us x squared divided by 9. That's it. These rules are actually super helpful. So please take some time to look at these, understand them. If you have questions, you can write them in the comments below. If you have questions about other topics in algebra or calculus, check out my YouTube channel and my algebra and calculus playlist. Thanks for watching.